Greetings to all. The session is regarding international chemistry, national level chemistry, and Telangana, Andhra Pradesh level chemistry will be discussed on the intermediate floor. This will be fetching for your entrance and competitive exams as well. On the international floor, national level JE advanced. JE means examination will be conducted twice a year in order to take the admission into IIT and NIT stream. Here, NEET exam will be conducted for medical admissions all across India. And next is about Telangana government, Andhra Pradesh government are conducting MCET examination to take the admission into BTech stream. Again, it is the technical domain. In addition, so many government organizations are conducting government job competitive examinations. There, general studies common content will be there. In the general science will be found. The session what we are discussing is very much helpful for your preparation. Let's enter into our today's session. Mention the possible isomerism in the given coordination complex. Here is the complex you can notice. This is the complex of chromium surrounded with six water molecules, and where the sphere is indicated with the positive 3 and 3 chloride negative ions are present at the same time. Another complex is there which is made up of chromium again, but one of the water molecule now replaced with the chloro, and outside the sphere you can notice two chlorides and one water molecule will be there. This is the way two complexes are mentioned and what relation, what isomerism it's said to be, that to be identified. Here are options provided: hydrate ionization isomerism, linkage isomerism, geometrical isomerism, tautomerism. Let's go with one by one. Hydrate ionization isomerism is the special kind of isomerism found in ionization. It is a part of ionization isomerism only, purely specific for hydrated molecule, that means water. Here being ligands are the water molecules, then only we can go for hydrate ionization isomerism. So within the given compound, you can find water, and there is a possibility of chloro replacement with water, so that it is the part of hydrate ionization isomerism. Linkage isomerism denotes if amphidentate ligand is present, then which atom is linking with the metal through coordinate covalent bond formation. That is said to be linkage isomerism. Geometrical stands for there is a provision to give the orientation around the carbon-carbon double bond, either cis trans or else EZ. That is the part of geometrical. Tautomerism is nothing but keto to enol form, enol to keto form that we can observe in organic moieties. So that the correct representation for the given isomers is about hydrate ionization isomerism. That is clearly given by the slide, where you can notice it is said to be either solvate or else hydrate isomerism, a special type of isomerism process where a very similar type of isomerism results from replacement of coordinated functional group, that is purely water molecule and replaced with the chloro, so that we will get the ionization into out to in the with the ligand exchange, and in specific water is the ligand can be exchanged, and this is purely applicable to the coordination number of 6. So this is the way water molecule is used to be exchanged with the outer ligands chlorides, so that the hydrate or solvent isomerism is observed. This is the way we can explain for this question number 1. Question number 1 related with the coordination complexes in accordance with the IUPAC nomenclature. IUPAC stands for International Union for Pure and Applied Chemistry, and these complexes isomerism is mentioned over. For question number 1, option number 1 is the correct answer. Move on to question number 2, which is collected from Cambridge Assessment International Examination Platform. It is the part of Cambridge Assessment part. And the question is, methanol is prepared by reversible reaction. Methanol can be prepared by reversible reaction by taking CO plus H2. I think everybody aware the mixture of CO and H2 is called water gas, which is also called as blue gas, right? CO and H2 upon combination gives rise to the methanol gas. And you can see double-headed arrow. Double-headed arrow indicates the reaction is reversible. Reversibility is said to be reactant to product feasibility, product to reactant feasibility. Both the directions reaction will be occurred forward and backward direction. And they are saying forward reaction is exothermic in nature. If you are moving towards the product formation, heat will be evolved during the reaction. If heat is coming out, which is said to be exothermic reaction. Which condition produce the highest equilibrium yield in the methanol? In order to get the highest extent of methanol, what conditions to be followed? And here the variables mentioned are, one is temperature, second is pressure. It's a most tricky question and is given from chemical equilibrium content. Here two parameters are taken into the consideration. One is temperature and other is pressure. In order to reveal the temperature effect, first of all, we have to observe the reaction is exothermic. Exothermic in the sense, in comparison to the reactants, product is having less amount of energy because that is liberating energy to some extent. In order to make this possibility, the lower temperature condition is required, then only forward direction reaction will be proceeded. So low temperature is the required condition with regard temperature effect. Move on to the pressure effect. Pressure effect, in order to explain the pressure effect, Le Chatelier principle plays a role. Let's see how can we explain both. In the step 1, we are going to discuss about exothermic, how temperature will show its effect on this methanol synthesis starting from carbon monoxide and hydrogen gases. According to Le Chatelier principle, reaction followed by release of heat favorable at lower temperature. Whatever reaction releasing heat, so that carried at lower temperature conditions, because low temperature effect offsets the change caused by the heat of the reaction, right? So since the methanol is desired product, wanted reaction is indeed exothermic, therefore we had wanted to proceed at low temperature. This is in accordance with the Le Chatelier. And as per the Le Chatelier, one more condition is mentioned over. If you are having more number of moles for the reactant side, less number of moles towards product side. What condition we have? At that case, pressure will show its effect. How? By decreasing the pressure. If you are going to decrease the pressure, the reaction moving towards equilibrium favors towards product side. So here total number of moles of product will be increased because less number of moles are there for this. By increasing the pressure, equilibrium shift towards the reactant side, so that you have to go for the decreasing the pressure. So let's see. If you observe the reaction between the carbon monoxide and hydrogen, 2 moles are there reactant side, 1 mole is there product side. In order to make the equilibrium shift towards the product side, so that less number of moles will be there, low pressure is applicable. Decreasing the pressure is favorable condition that is available, low at the option D. For question number 2, option number D will be the correct answer. Here lower temperature to be maintained and lower pressure also maintained, so that a product methanol will be accorded in the higher yield. This is the way Le Chatelier principle plays a role in the chemical equilibrium. Move on to question number 3. Question number 3 collected from JEE Advanced 2017 paper 1 question paper. IUPAC name of the following compound. IUPAC stands for International Union for Pure and Applied Chemistry, and this is the compound where you can notice benzene ring with methyl and chloro. IUPAC name to be assigned. In order to give the IUPAC name, you can notice chloro is there, methyl is there at 1,4 position. Which is 1, which is 4, we need to identify. The expected answer is 1 chloro 4 methyl benzene. Let's see how can we make the order. So on the chloro side, you can put 1 number. This is in accordance with both the factors. According to higher atomic number chloro, according to alphabetical number chloro. So that one will be started from chlorocarbon, later on 2, 3, 4. So that methyl is accorded, methyl carbon is accorded with the fourth number. Let me mention 4 methyl and 1 chloro benzene. 1 chloro 4 methyl benzene is the right naming, because in accordance with the alphabetical order, C comes first over M. So that let me write 1 chloro 4 methyl benzene as the IUPAC name. For question number 3, option number C will be the correct answer. Move on to question number 4. Question number 4 is also the part of organic chemistry. The correct statement for the following addition reaction. This is the trans 2-butene. This is cis 2-butene. In both the conditions, you are going to apply bromination under chloroform. Bromine dissolved in chloroform will be reacted. Mixture of two products you can achieve, and even cis 2-butene also bromine chloroform gives rise to mixture of two products O and P. They are saying that MO and NP are two pairs of diastereomers. Bromination proceeds through the trans addition in both the reaction. This is perfectly correct. Wherever bromination is there, that is always trans addition only. OP are identical in molecules. We have to check out them. MO and NP are two pairs of enantiomers. That also we need to identify. In order to get the answers here, 1 and 2 to be proceeded with the bromination, we will discuss in detail. Whenever trans, this is called what? Trans 2-butene. Why it is called trans 2-butene? Because two methyl are laying opposite with respect to each other in accordance with the double bond, and bromine chloroform will be added over. Whenever bromine chloroform is added, two bromines are added, either being it is a trans, and again bromination is trans. Trans compound trans addition gives the cis isomer, cis product. That means the two bromo on the same side. I think I am very clear, because already existing compound is trans. Bromination is also said to be trans, so that two bromo are coming on the same side, that is either right hand side or else the left hand side. Both the provisions you may have, M and N we can write, right? M and N can be attained. In the option A, MO and NP, two pairs of diastereomers. Let's see whether it is correct. So we have to go for OP also, right? Only MN part we completed. Move on to any other reaction. We are going with what? Cis butene. The cis butene is accorded with the bromine chloroform. Whenever bromine chloroform is treated with cis butene, what happens? Cis is of two functional groups are on the same side. As already you're aware, bromination is of anti-addition. Anti-addition gives rise to the two bromo in the anti-position with respect to each other. That have two provisions, either right hand side bromo, left hand side bromo, left hand side bromo, right hand side bromo. So these two are O and P. At this condition, you can say that MO. So if you take M, both the bromo on the same side, and if you take O, bromo are in the anti direction. MO and NP have no mirror image relationship, and hence two pairs are said to be diastereomers. So that whatever mentioned in the option A is perfectly correct. MO is diastereomeric one, NP is also diastereomeric one. So that this is correct. And always remember, whenever we are going with the direct bromination, that is said to be trans addition. Bromination is always a trans addition, because one of the bromo when added, that used to form a ring type of structure with the bromonium ion formation that can occupy the entire sphere wherever bromo is there. And another bromo have only one provision to come in the opposite direction. Already one side completely occupied by one bromine, right? So that next bromine can occupy, can come inside from the in either direction, in either side only. That's the reason we're always bromination or any halogenation process is said to be anti-addition or trans-addition. A is correct, B is also correct. So A, B are the correct answers. You can notice here. In accordance with these chemical reactions, we can explain. Move on to question number 5. Telangana IMSET 2022 question paper was taken into the consideration for chemical question segment. For photoelectric effect, which of the following statements are true? The kinetic energy of photoelectrons do not depends upon the frequency. Photoelectric effect will always occurs when highly intense light is taken. The maximum kinetic energy of photoelectron does not depends upon the intensity of light. The escaping electron's kinetic energy is larger for larger frequency. Four options are provided. We need to identify which are correct. Multiple answers may be correct. So that 1, 2, 2, 4, 2, 3, 3, 4, 4, 1. Which are correct? Only 3 and 4 are correct. The third option, fourth option is correct. Let's check how can we explain this. In order to explain the photoelectric effect, this is a Nobel Prize winning concept by Einstein scientist. Photoelectric effect is applicable to the metal surface whenever you are irradiating with the photon light, so that electrons excited and they will eject from the surface. This is a common phenomena, everybody aware. Whenever photoelectric effect are related with the incident light frequency by following equation. Photoelectric effect energy and frequency are related by this equation. EK, kinetic energy of photoelectrons or photons, is equal to EVS is equal to h nu minus pi. Pi is equal to h nu naught is the work function of material. Ek is the kinetic energy of photoelectron. Ek is equal to h nu minus h nu naught. Okay, if you observe the entire equation, the statement what they are saying, frequency of light do not depends upon the frequency of light they are saying. But if you see energy is equal to h nu minus h nu naught, nu for what? Frequency only, no? So that kinetic energy of the photon directly proportional to its frequency. They are saying there is no relation, doesn't depend, but there is a direct proportionality, so that we can cancel the option 1. Move on to option 2. Photoelectric effect will always occur for highly intense light. Right. So emission mechanism. So highly intense light is required or not, we have to screen out. Photons of light beam have a characteristic energy called photon energy. Photon associated energy is called photon energy, which is proportional to the frequency of light. Just now we said no. As the frequency of light increases, kinetic energy also increases. Photoemission process, when the electron with some material absorb the energy photon and acquires more energy than the binding energy. Whenever the material surface is irradiated or bombarded with the photon, the surface of the material will enhance its energy, so that enhanced energy responsible to eject the electron. That is the way the process carried, but not depends upon the intensity of light. Even in the equation, you can't see any term, any parameter which mentioning intensity of light in order to measure its photon energy, so that you can cancel out option number 2 also. And option 3, maximum kinetic energy of photoelectron doesn't depends upon the intensity. So in the option 2, they are saying depends upon intensity. We are saying doesn't depend, so that we can go for option number 3 only, because within the equation they doesn't mention any intensity parameter. So doesn't depend is the correct answer instead of depends upon the intensity of light. So that's third option will be the correct one. The escaping electron's kinetic energy is larger for larger frequency. That can be explained over here. Higher energy light ejects the electrons with the higher kinetic energy. If the energy of electron is larger, then kinetic energy of that electron is also larger. So this is the way you can go for the option number 4. That is perfectly strengthened by the statement what we mentioned, and that is given by Photoelectric Effect Photon Cone Academy. So that is exactly mentioning what they are saying. So fourth one is also correct answer. For question number 5, option number 3 is the correct answer, with the third and fourth are appropriate answers, right? Move on to last question of the session. Which of the following statement is not true? Which is not correct to be identified? Electromagnetic radiation made up of particles called photons. This is perfectly correct. A small packets of energy will be there. Those small packets of energy are called photons. Photons associated with the energy is equal to h nu. right? Electromagnetic radiation entirely made up of, everybody aware electromagnetic radiation is having dual property. One is called particle nature, second is called wave nature. Particle nature is clearly supported by these packets, energy packets called photons. Each photon move with the speed of light. Always, photons are tiny particles, and they are, if they are traveling in the vacuum, they are having the exact same speed as a light. So, because being photons are neutral in nature, though it is in contact with other particles, that will not impact it. Rather, they will move with the speed of light. Okay, being these are tiny particles, so that whatever speed of light we have, 3 into 10 to the power 8, same will be applicable to photon as well. Photon energy is dependent on the intensity of radiation. That's perfectly wrong. The photon energy dependent upon the frequency, but not on the intensity. Just now we repeated the equation called E is equal to h nu. H is the Planck constant, nu is what? Frequency, but not intensity. So that photon energy dependent on the intensity is a wrong one. So we identified this is the correct answer, not true to be depicted. And photons are not deflected by electric and magnetic field. Electric vector and magnetic vector both are perpendicular with respect to each other. Perpendicular means what? If one is traveling in this direction, another is traveling in this direction, both are right angle with respect to each other, 90 degrees angle will be there. Whenever electric field is applied in the path of photon, whenever magnetic field is also applied, photons will not be deflected, they will not be deviated. By because photons are neutral in nature, so that they will not be influenced by means of electric vector and magnetic vector. So this is correct. All the answers whichever provided are correct except the third one, so that it will be taken as the answer for the question number 6. Let's go with the detailed explanation. Everybody aware, photomagnetic radiation is the categorization all the segments in accordance with the decreasing of energy or else decreasing of frequency or else increasing of wavelength. In 3 parameters you can go for the explanation. One is with respect to energy, second is with respect to frequency, third is with respect to wavelength. Okay, so entire segmentation got carried in accordance with the decreasing of energy, decreasing of frequency, increasing of wavelength. So that highest energy will be a gamma ray, next level X-ray, next level ultraviolet in combination with the visible. Visible is the 7 colors. Infrared light will be there. Next level microwave is the next segment, and radio waves of least energy level. This is the way all the segments got categorized. They are saying that electromagnetic radiation, so that the photon is an elementary particle with the quantum electromagnetic field included with electromagnetic field. So it is the part, photon is the part of electromagnetic field. Photon is an elementary particle that quantum of the electromagnetic field, including electromagnetic radiation, light and radio waves. Okay, and here the speed of light, the photons are massless. Photons are light in weight. We can't measure the weight of them because they are massless, so they always move the speed of light. So even in the vacuum, okay, 299792458 meters per second. Simply we can write round up as 3 into 10 to the power 8 meter per second. Okay, so the photon belongs to the class of boson particles. Boson particles also well known, which are also the part of nucleons, and tiny particles will be there. The speed of light, whatever present photons also acquiring resembling speed. Here is the formula for the photon is equal to hf, f for frequency. You can mention nu, you can mention f as well. Is equal to h nu or is equal to hf. H is a Planck constant. Here it is clearly mentioned. Is equal to f. Frequency can be replaced with c by lambda. C for velocity of light, lambda for wavelength of light. Okay, here let's see the entire description of this equation. E for energy of photon, H for Planck's constant, whose value is 6.62607015. into 10 to the power negative 34 joules second kilogram meter square second inverse. The value remains same. F for photon energy, lambda for photon wavelength, C for speed of light, which is taken as 3 into 10 to the power 8 meter per second. Okay, so one photon energy, one H is equal to 6.6 into 10 to the power 34, and Planck constant in terms of electron volts 4.14. One photon energy is 4.14 electron volts into 10 to the power minus 15 electron volts. This is the way entire equation for the photon energy can be derived. Now, let's go with what is photon. Photon is also known as light quantum. It is the minute energy packet, small packets energy is transmitting, we said no. So this clearly mentions the particle nature of the wave. Particle nature of the wave evidented by these photons. These are the packets of energy. Electromagnetic radiation. Photon arised in the year 1905. Albert Einstein is the seeding inceptor of this photon by means of the Nobel Prize winning effect called photoelectric effect, in which he suggested the presence of discrete energy packets during the transmission of light. Einstein deduced that light quantum could also associated with the momentum h nu by c, right? A substantial energy value momentum strongly indicated light quantum could be associated with the particle nature. Just now we said light photon is having particle nature. This particle was later named photon. Therefore, photon defined as a discrete bundle, which is also known as a quantum. It is the magnetic with the magnetic energy. Since photons are massless, they move with the speed of light, that is 3 multiplied with 10 to the power 8 meters per second. Here our required concept is photons are electrically neutral. This is the one I would like to elevate. Photons are electrically neutral or not deflected by electrical and magnetic fields. Being these are neutral in nature, can't be affected by electric field and a magnetic field as well. Let's go with the options once again. Electromagnetic radiation is made up of particles called the photons. Just now we explained in detail. These are also called as quantums. Each photon moves with the speed of light. That is also correct. 3 into 10 to the power 8 meter per second in quantification value. Photon energy is dependent on the intensity of radiation is equal to h nu or else is equal to hc by lambda. You can't find any parameter like intensity, so that you can cancel out. Photons are not deflected by electric magnetic field. Being these are neutral, they can't be deviated, they can't be deflected by means of electric field, magnetic field. By this entirely, the session was completed successfully. Hope the session is really informative and we covered with the various corners and in specific atomic structure got discussed over chemical equilibrium topic, IPAC nomenclature, coordination complexes are dealt with, and diastereomerism, enantiomerism concepts taken into the picture, and bromination. So many different segments of chemistry got covered over. Definitely the kind of session will increase your thirst towards learning of chemistry, and you will be chemholics, means need to learn more about the chemistry is called chemholic in nature, right? So I hope this is really helpful for your preparation. Hence I'm sincerely requesting all to like the channel, comment. There is a question regarding the entire session in the isomerism of, in the, if you want to discuss about isomerism of coordination complexes, how many types you know about coordination related isomerism, isomerism observed in the coordination complexes, how many isomerism process you know, that you can comment in the comment box and share with the aspirants who are serious about the preparation. Subscribe the channel. Thank you for watching. Thank you one and all.